Hello, this is Professor Kuehn, and welcome back to Introduction to Astronomy, where we are looking at Galileo Galilei's famous work, The Starry Messenger. You might remember in the last few lectures, we looked at Chapter 18 in A Student's Guide Through the Great Physics Texts. And in that chapter, we talked about Galileo's telescope that he was using, and we focused primarily on his observations of the moon. For instance, he was able to calculate the height of a mountain on the moon. He noticed many mountains and valleys, and the central claim was that the moon is made of a material much like that of the Earth. This is a bit controversial, remember, because up until this time, the view was really prevalent that the heavenly objects, the moon, the sun, the planets, and so on, are made of some fifth substance, an ethereal substance very different than that of the things here on Earth. What Galileo is saying, well, not at all. The moon is made of the same kind of rocky substance that the Earth is. To be sure, the Pythagoreans in ancient times had already speculated that the Earth was made of, that the moon was another Earth. It was made of the same kind of thing. But that idea was not popular, you might say. And so really here we have, with Galileo's telescopic observations, the first direct experimental evidence that the moon is made of the same kinds of elements that the Earth is, or at least strong evidence that it is. Now what I'd like to do is go on to chapter 19. This is the second half of the Starry Messenger. And in this chapter, I have it open here on the side of my screen. This is on page 249. It's called the Medician Stars, because remember, what Galileo is going to describe in here is his discovery of the 4 moons of Jupiter that he calls the Medician Stars. Don't be confused. The terms, sometimes he'll call them the Medician stars, sometimes he'll call them new planets he's discovered. We today call them the moons of Jupiter, but there's not a settled terminology at this point. Remember that when you look up at something like Jupiter or Mars or Venus, really it does look like a star. So literally planet means wandering star. So there's sort of a little bit of an ambiguity here about what these things are made of. We've by now settled on a terminology. We talk about the sun, the stars, the moons, and the planets, but here you kind of see a snapshot, as it were, of how they're working these things out in the late 1500s, early 1600s. Okay, so let's jump ahead to the next page, and the first thing he talks about on page 250 is how when you look through a telescope at an object like Venus or Jupiter, it appears greatly magnified, and yet if you look at a star, for example, the star does not appear greatly magnified. It appears to be the same size. Sometimes perhaps you've had this experience where you look at a planet through a telescope like Jupiter and it looks quite big, but if you look at a star, it doesn't really look any bigger. And so he provides an explanation of why this might be at the top of page 250. He basically argues that when you're looking at a planet like Jupiter, you're actually seeing the body of Jupiter itself. And so when you look through a telescope, that body of Jupiter is in fact magnified. But when you look at a star, you're not actually seeing the body of the star. You're seeing kind of a halo or disk of illumination around it. And this, by the way, is shimmering as it's moving through our atmosphere. That's what gives rise to the twinkling of the star. So when you zoom up on it, you're not really zooming up on the body of the star itself. You're simply trying to amplify the shimmering disk of light that's surrounding the star. At the bottom of page 250, Galileo goes on to talk about his observations of Orion. He says, as my first example, I determined to depict the entire constellation of Orion. So he's going to look at Orion through his telescope and make a sketch of what he sees. And he says, but I was overwhelmed by the vast quantity of stars and by want of time, and so I have deferred attempting this to another occasion. For there are adjacent to it or scattered among the old stars more than 500 new stars within the limits of 1 or 2 degrees. So he depicts in figure 19.1 the constellation Orion, or at least a belt of Orion, and the sword hanging down, and he draws as small dots there all the new stars that he's able to see through the telescope that one is not able to see with a naked or unaided eye. And then he goes on in the next paragraph, this is at the last full paragraph on page 251, to talk about the Pleiades in the constellation Taurus. So he shows the 7 sisters, or rather the 6 ones that are most visible, surrounded by many other stars that are only visible through a telescope. Next, he looks at some of the nebula. So you might remember what a nebula is. A nebula is basically a small puff or whiff of it looks like a cloud up in the sky. And people were aware of these, they called them nebula, but what Galileo does is he points his telescope at them and finds that some of them are comprised of very many tiny stars. So what we thought of as a cloud was actually a bunch of stars. He says, "For upon whatever part of it you direct the spyglass, straightway a vast crowd of stars present itself to view. Many of them are tolerably large and extremely bright, but the number of small ones is quite beyond determination." And he goes on in the next paragraph to say, "Furthermore, and you will be surprised at this, the stars that have been called by every one of the astronomers up to this day nebulous are groups of small stars set thick together in a wonderful way. Although each star escapes our sight on account of its smallness or of its immense distance from us, from the commingling of their rays there arises that brightness which has hitherto been believed to be the denser part of the heavens, able to reflect the rays of the stars of the sun." So he's saying here that at least some of the nebula, these whiffs of white color, are in fact clusters of stars. Okay, now he goes on the next page to talk about what he says is his most significant discovery. He says on the top of page 253, the first full paragraph, "There remains the matter that seems to me to deserve to be considered the most important part of this work." And he goes on to talk about "I should disclose and publish to the world the occasion of discovering and observing 4 planets never seen from the beginning of the world up to our own times, their positions, and the observations made during the last 2 months about their movements and their changes of magnitude. And I summon all astronomers to apply themselves to examine and determine their periodic times, which it has not been permitted me to achieve up to this day owing to the restriction of my time." So what he's doing is he's going to describe how he was looking at Jupiter and he discovered 4 new tiny stars in the vicinity of Jupiter. And like a good professor, he's suggesting to his students, if you have time to look at this, there's a lot of work that can be done here, a lot of interesting discoveries that can perhaps be made by doing accurate measurements of the motion of these new stars around Jupiter. And so for the next 2 or 3 pages, he's going to describe in some detail these observations. So what I want to do is I want to kind of pick out a few things to highlight here. So he says, "On the 7th day of January of the present year, 1610, at the first hour of the following night, when I was viewing the constellations of the heavens through a spyglass, the planet Jupiter presented itself to my view. As I had prepared for myself a very excellent instrument, I noticed a circumstance which I had never been able to notice before, owing to want of power in my other spyglass." So his other telescopes were not powerful enough, but apparently this one is. He says, "That is, 3 little stars, small but very bright, were near the planet. Although I believed them to belong to the number of fixed stars, yet they made me wonder somewhat, because they seemed to be arranged exactly in a straight line parallel to the ecliptic." Remember, that's the line along which the sun and the planets travel. "And to be brighter than the rest of the stars equal to them in magnitude. Their positions with reference to one another and to Jupiter follows in figure 19.5. So figure 19.5, this is a diagram that Galileo prepared that shows Jupiter in the middle, 2 little stars off to the east and 1 off to the west. Now keep in mind that it is not, you're kind of expecting these to be the moons of Jupiter. That's not what Galileo is expecting at all. He says here that he anticipated that when he was looking at Jupiter, he was simply seeing 3 stars that were behind Jupiter. They were part of the regular constellations, and maybe he just hadn't seen them before. So he didn't really make that much note of them, except to notice that they're all in a straight line and they're a little bit brighter than one would anticipate. Okay, and so the next thing that he does is he goes back and looks at it a few nights in a row, and he notices something interesting, that they're in different configurations relative to Jupiter. So he shows in the next few diagrams what happens. So he says, "On January 8th, led by some fatality, I turned again to look at the same part of the heavens. I found a very different state of things. There were 3 little stars all west of Jupiter, and nearer together than on the previous night, and they were separated from one another by equal intervals, as the following illustration shows in 19.6. So there you have the 3 stars and Jupiter. And what he notices is that they're a little bit closer together than before, which, I suppose he might think maybe I just didn't really note properly how far they were apart before, but he seems to think that they're closer together. And he says, at this point, although I gave no thought at all to the fact that the stars appeared closer to one another, yet I began to wonder how Jupiter could one day be found to the east of all the aforesaid fixed stars, when the day before it had been west of two of them. Okay, so it's changing its location relative to those stars. And notice that this isn't necessarily a bad thing, because after all, remember the fixed stars, the planets wander through them. It progresses through the zodiac, right? So he's thinking maybe it's just going through the zodiac, but it would have to be undergoing retrograde motion through the zodiac, right? In order to do this, because it would be moving in the eastward direction through the zodiac. And so he says, and forthwith I wondered whether the planet might have been moving with direct motion contrary to the calculations of astronomers, and so might have passed those stars by its own proper motion. So in other words, he thought that the Jupiter should be moving through the zodiac in one direction, but this seemed to suggest it's moving through the zodiac in the other direction. He says, I therefore waited for the next night with the most intense longing, but I was disappointed in my hope, for the sky was covered with clouds in every direction. But on January 10th, the stars appeared to the following position with regard to Jupiter. There were only two, and both on the east side of Jupiter, the third, as I thought, being hidden by the planet. They were situated just as before, exactly in the same straight line with Jupiter, and along the zodiac. After seeing this, I understood that the corresponding changes of position could not by any means belong to Jupiter. Moreover, I knew that the stars I saw had always been the same, for there were no others either in front or behind within a great distance along the zodiac. Finally, changing from perplexity to amazement, I became certain that the observed interchange of positions was due not to Jupiter, but to the said stars. Thus I thought that henceforth they ought to be observed with more attention and precision. So he's saying here that he's noticing there's a change in the configuration of Jupiter compared to the stars, and he's noticing now that it's actually the stars that must be moving, but they're going right along this straight line, and they're kind of they're changing their spacing and their location with respect to Jupiter. Okay, and if you go on to the large paragraph on page 254, I want to pick out a sentence here. He says, I therefore concluded and decided unhesitatingly that there were three stars in the heavens moving around Jupiter, like Venus and Mercury around the Sun. This was finally established as clear as daylight by numerous other subsequent observations. These observations also established that there are not only three but four wandering sidereal bodies performing their revolutions around Jupiter. So there he's really coming to the conclusion that these stars are actually orbiting around Jupiter, and in fact there are four of them, not three, as he depicts on the top of page 255. And so then what happens here is he goes through a series of observations. I've actually left some of them out, where he draws pictures of these moons of Jupiter at various configurations around Jupiter. I've just given you a flavor for the kind of approach he's taking to studying this. Let's look at the last paragraph on page 255. He says, these are my observations of the four Medician planets, recently discovered for the first time by me. Although I am not yet able to deduce by calculation from these observations the orbits of these bodies, I may be allowed to make some statements based upon them well worthy of attention. And now what he's going to do is explain a few things that are notable. He says, in the first place, since they are sometimes behind and sometimes before Jupiter at like distances, and deviate from this planet toward the east and toward the west only within very narrow limits of divergence, and since they accompany this planet when its motion is retrograde as well as it is direct, no one can doubt that they perform their revolutions around this planet, while at the same time they altogether accomplish orbits of 12 years duration around the center of the world. So in other words, they're staying tightly tied to Jupiter, and when Jupiter is progressing through the zodiac, they progress with it. When Jupiter is retrograding through the zodiac, they retrograde with it. And so they along with Jupiter, take 12 years to go around the center of the world, that is around the sun. He says, moreover, they revolve in unequal circles, which is evidently the conclusion from the fact that I never saw two planets in conjunction when their distances from Jupiter was great. whereas near Jupiter, 2, 3, and sometimes all 4 have been found closely packed together. So in other words, the moons have very different orbits, different sizes. And how does he know this? Because when one of them is very, very far away from Jupiter, kind of the longest angular elongation from Jupiter, there are never 2 of them right next to each other at a very extreme angular elongation. But oftentimes you might see 2 or 3 or even 4 of them very close together when they're close to Jupiter. So that means that at least the outer one is in its own orbit. Okay. Furthermore, it may be deduced that the revolutions of the planets that describe smaller circles around Jupiter are more rapid, for the satellites nearer to Jupiter are often seen in the east when the day before they have appeared in the west, and vice versa. Also, the satellites moving in the greatest orbit seem to me, after carefully weighing the timing of its return to positions previously noticed, to have a periodic time of half a month. So the ones that are orbiting close to Jupiter do so very quickly, and the one that's in the widest orbit takes about 15-20 days to go around Jupiter. Okay. By the way, this is something that Kepler is going to pick up on and Newton is going to pick up on when they talk about Kepler's law of planetary motion. And I guess not Kepler, but primarily Newton talks about this when he's developing his universal law of gravity. Let me read the very last paragraph on the bottom of page 255, where he offers a criticism of those who are rejecting the heliocentric view. He says, "Additionally, we have a notable and splendid argument to remove the scruple, or the disagreement, of those who can tolerate the revolution of the planets around the sun in the Copernican system, but are so disturbed by the motion of one moon around the Earth, while both accomplish an orbit of a year's length around the sun, that they think this constitution of the universe must be rejected as impossible." In other words, there are people who reject heliocentrism, the sun being at the center. Why do they reject this? Because they think it would be very weird or perplexing to have the moon going around the Earth as a center and the planets going around the sun as a center. After all, why would there be 2 centers? That seems very strange, and on account of that strangeness, people are rejecting the heliocentric system. They say actually everything is just going around one center, that one center is the Earth. He's saying that that's not, I want to remove that objection, is what Galileo is saying. He's saying for now, we have not just one planet revolving around another, the moon going around the Earth, while both traverse a vast orbit around the sun, but we have 4 planets which our sense of sight presents to us circling around Jupiter, like the moon around the Earth, while the whole system travels over a mighty orbit around the sun in the period of 12 years. So it's not only strange that you have 2 centers, the sun as the center of the solar system and the Earth as the center of the lunar orbit, but now you have another center. You have Jupiter as a center of an orbit of its 4 planets around it. Okay, so let me see. Do I want to comment on the very last paragraph? In the very last paragraph, he spends a little bit of time trying to explain why it is that the moons of Jupiter, when they are orbiting Jupiter, sometimes grow in size greatly. They sometimes seem twice as big and sometimes half as big. And he tries to explain that in terms of the atmosphere of Jupiter